So Connor, here we have the UH650. What can you tell me is different about this machine to the UX450?
Yeah, so really a lot of what Ian said already applies to this in terms of technology level that's available. Main differences between this machine is going to be obviously footprint. It's a larger bed size, so we can take more components on. Main difference would be with the Blum tool measurement.
Yes.
So we're not using a camera system on here, we're using a spot diameter beam to measure the tool length. Again, very accurate, very reliable way of setting the tools up.
So we offer Blum, don't we, because we feel they're the leading in the industry.
We do. I mean, it's industry standard really in terms of laser measurement systems. So yeah, very accurate, very reliable. And again, it's all about the speed of the axis, what we can move. The linear motor technology is just second to none really, just for that accuracy and repeatability.
And we can see that, can't we, on the finish of the trophy, which we're going to look at on a scanning device from Hexagon shortly. But visibly, it's easy to see the capabilities of this machine and how it can smooth and how it can polish.
Oh yeah, definitely. So, for example, a lot of sort of maybe EDM applications that you would have done previously, there's potential here that you can, say, put the mould straight on the machine and do a bit of hard milling rather than manufacturing electrodes and then sparking.
Yeah, and it sits nicely, doesn't it, within the portfolio of the Sonic machines. So not only do you look at die sinking for mould tools, we can lend it to milling, so the applications go hand in hand, and we've got unity across the platform and the control also.
Oh yeah, that's it. So the fantastic thing about the Sonic control is that it's uniform from machine to machine. So EDM, hole drill, wire cut, even the milling, you can get on there and pick it up straight away.
Yeah, and obviously we've got a visual on board if you can't see the application going on. And it's the environment that you look at when you're working on the Sonic machines. As Ian touched on earlier and Connor's just said, the fast paths are really easy. So from a user point of view, there's a lot of commonality, very friendly to use. I mean, how do you find this from going from NC program to actually setting the job and working?
Oh, it's really easy. So realistically, you can get a part on there and get it cutting within 10 minutes.
Yeah, which is great for upcycle time, isn't it?
Yeah, fantastic.
Also, we've got quite a lot of energy-saving features within this machine, haven't we?
Yeah, there is. So when the machine's not active after cycle, if it's just sat idling, then it will automatically shut itself down, so the spindle's not running for hours where it's not cutting metal.
Okay, so we've spoke about the machine tool control. Let's look at what we're machining on now. We've got the longest drive trophy. What can you tell me about that and the process we've worked through to get to this stage?
Yeah, so that's a hardened piece of Stavax, that's 55 Rockwell, so quite difficult, quite tough to machine. We're doing that with a series of cutting tools from 2mm end mill all the way up to a 6mm ball nose.
Which is quite small, isn't it, an inch?
It is for that level and depth of cut that we've gone for.
And the hardness of the material.
Yeah, definitely.
Yeah, okay, that's brilliant, Connor. So what we'll do, we're going to have a look at how Hexagon can now scan this part and see if the imperfections or if there's anything on that tool that Connor's been producing. So I'll pass you over to Paul from Hexagon. Okay, and Connor's going to join in and we're going to have a look at what's going on over here. If you want to make your way round, you can physically see what we're doing on board the screens.
Hi, so I'm Tom from Hexagon. I'm part of the metrology apps team over at Hexagon. Today we've got an absolute arm with us. They vary in length from 1.2 to 4.5 meters, so it can cover a varying envelope of measurement for your part then. The accuracies vary from 0.029, so like 29 microns, up to about 158 accuracy MPE for the arm itself. We've got changeable probe tips and the AS1 scanner. The AS1 scanner itself is 13 microns accuracy, so very accurate. We've got a AS1 XL, which has a much wider stripe length, so depending on the part you're doing. It's got like 700mm standoff for the floor, so it could almost hold it at waist length and be able to scan the floor. You've got quite a wide stripe, so big, large components scan great in that. The accuracy is slightly more, 134 microns for the XL, but depending on the parts, is a great one for that.
So that gives us quite a big part range, doesn't it? So
Yes.
not only can you measure something so intricate and so small, you can measure something that's quite vast off the floor.
Yeah, we've measured everything from very small components all the way up to a full train car with the XL. So you've got a vast portfolio of different items you can scan then within that.
Brilliant, brilliant. That's really interesting.
So I'll just scan directly into Visi here, just because it makes more sense for the mold and die industry, reverse engineering, and you can see a bit of the data that it can capture then. So you've got an envelope for the scanner itself, so all you do is align the blue laser with the red sort of center point of that envelope. As long as it's within the envelope, you'll get your scan data. You also have visual feedback on the back of the scanner. Green is good, blue and red, you're just moving outside that envelope. It's just giving you a bit of a warning. And then nice and easy to manipulate. You've got, this is a 7-axis model, there's also a 6-axis model, encoders in all the different joints, and just gives you a real high level of accuracy for your measurements then. But the scanner itself has something called shine technology, which auto-exposes to multiple different materials at the same time, so you don't have to keep changing your exposure levels when you move in from one material to another. It'll automatically set all of that for you. And then you've got the probes as well. So the probes and the scanner are all interchangeable. So all you'd have to do to swap off the scanner is unclip it, take it off, swap it for the XL. And then the probes also have a chip in, which is great. So once you calibrate it once, you don't have to calibrate it every time you swap it on. You can change from 6mm ruby to the 3mm to the 15mm and swap it nice and easy, unclip, take it off, pop on your new one, clip it on, and you're ready to go and measure with the probe then.
So it's a really versatile piece of equipment.
Yeah, it's excellent for almost every sort of part you want to try and measure then. We've also got inspection softwares, so there's Inspire, you can use it with Polyworks, you can use it with Spatial Analyzer, lots of different inspection softwares for all your sort of metrology, GD&T applications and that kind of thing. Obviously in this practice we're just using Visi and then you're doing your reverse engineering off it then.
Brilliant. Well, that's given us a really good insight into how we can scan things offline, how we can reverse engineer, how we can bring things back in. Thank you for talking us through that.